For this one, we're going to look at the function f of x is equal to 2e to the x cubed. Okay, this is a combination of the e to the x function along with something else. And so keep in mind the format we're going to be using here for taking the derivative all derives from the derivative of e to the x. Derivative of e to the x was just e to the x. However, when we talk about the derivative of e raised to something more up above, say e to the f of x, we'll still start with e to the f of x, but by the chain rule, we'll need to multiply by the derivative of f prime of x for what's up above in the exponent of e. Okay, and so when we write down the f prime of x here, we'll still write down 2e raised to the x cubed. That part doesn't change, but we still have to multiply here to the side by the derivative of the x cubed. So we're going to write down next to it 3x squared. So that's how we're getting the 3x squared there. We still keep the original 2e to the x cubed, but then we also have to multiply by the derivative of x cubed from up above. Let's go ahead and rewrite that slightly differently. Let's write that as 2 times 3x squared e to the x cubed. Just rearranging things a little bit. So that would be the same thing as 6x squared e to the x to the third. Okay, let's look at another one here, 15x e raised to the 2x. In this case, we're going to need to consider the product rule. We've got the first, that'll be the 15x on its own as its own thing to take the derivative. And then we also have the second, which is the e to the 2x. So when we write down f prime of x, we'll write down the first, 15x, times the derivative of the second, which is the derivative of e to the 2x. The derivative of e to the 2x still has e to the 2x. Also, we'll need to multiply by the derivative of the 2x, which is 2. So that part will go e to the 2x times 2. First times derivative of the second, plus the second, e to the 2x times the derivative of the first, derivative of 15x, just 15. So we'll write this as f prime of x is equal to 30x e to the 2x plus 15e to the 2x. Now for me, that's an okay place to stop. If you do look in the answer key for the review, in the similar example that's on there, it will have you factor it slightly. So to show what that would look like in this case, the greatest common factor of both terms is 15e to the 2x. So if we go through and factor out that, we could write this as 15e to raise to the 2x. That's the GCF. And next to that in parentheses would go 2x plus 1. That'll be left over after factoring out a 15 as well as the e to the 2x that they both have in common here. Okay, on this one, y equals ln 15x to the fourth plus 3x. Okay, now on this one, keep in mind that the derivative rule for ln of f of x is equal to f prime of x divided by f of x. I often again like to think of this as the derivative of what's on the inside divided by what's on the inside. So the inside part here is the 15x to the fourth plus 3x. So when we write down y prime, it'll be equal to, underneath, we'll just put what's on the inside, 15x to the fourth plus 3x. On top, we'll put the derivative of the 15x to the fourth plus 3x, which would go 60x to the third plus 3. And in this case, that's all we'll have to do.